Good. All right. So we're on top of the hour. Last session for today is Nick Salem's presentation. Nick, for those of you who don't know him, Nick is a distinguished member of technical staff at Neustar, and he is the principal software architect behind the Element One platform, which is already mentioned previously, and which he'll be talking about in a moment. He has over 18 years of experience in developing enterprise geospatial applications. And I don't know how long I have known him, but probably almost as long. He has been involved in the spatial SIG for almost as long. He currently serves as the technical chair on the board of the Oracle Spatial and Graph SIG, so one of the great volunteers. Thanks a lot, Nick, for all the work you put into this, first of all. And thanks for joining us from, I believe, his home office in the beautiful city of Prague in the Czech Republic. So, Nick, over to you.
Thank you, Hans. It's a pleasure for sure to be part of this event and all these great sessions that we've had and the unique use cases. So let me get started here. Hold on. So a little bit about myself, like Hans alluded to. So I've been working with geospatial and spatial applications for many years. It's been around 11 years currently at Neustar, and prior to that, 10 years at Nielsen Claritas, and just had the privilege to work in the spatial area. It's been very interesting use cases and solving the interesting problems. And one thing that's been really helpful to me over the years has been getting all these certifications in different areas of Oracle, building knowledge in kind of all the core database technologies. And this really helps me understand how everything works together, how to maximize throughput, strengthen security, maximize high availability, and squeeze as much performance out of the application. So all those, just understanding how all the pieces work together has been very helpful for myself. And like I said, because working with a spatial area for many years, the Oracle Spatial and Graph technology, and I've been leveraging it for many years now, has been really a powerful toolkit for us to leverage, a powerful, really rich technology stack that you can do a lot of different things. So definitely enjoy working and participating with the spatial SIG and seeing how we can further grow collaboration and exchange of ideas in the community. So it's a really very powerful capability. So just quickly on our agenda today. So I'm going to I have a number of slides on Neustar, and I'm going to go through them quickly. But Neustar has some pretty amazing technology and data assets that it can that clients leverage. So I'm going to go through some of that, and then I'll go at high level some of the use cases, the spatial use cases that our customers use. That Neustar provides solutions to our customers that are spatially driven, and I'll be focusing on some of these different use cases. And then I'd like to do a little demo of some of those to kind of bring to life some of those examples that we'll be talking about. So, Neustar, just a quick introduction of Neustar. Neustar is a good sized company. I think it's got about 1,500 employees, and it's been around for about 20 years. And it initially started in the telco space with like caller ID and telco services, and over the years moved more and more into analytics and security, and that's where a lot of the focus at Energy has been for Neustar over many years now. And they brought, like I said, they built a lot of great technologies and data assets in that area. So there's something at a high level. Basically, what Neustar does, it tries to provide intelligent analytics. Let me start my video here. It tries to provide intelligent analytics to our customers, and basically, so they can grow their customer base, they can better understand their customers, and they can improve the interaction with our customers. So the more they understand and know how their customers, the more details they understand with the customer, the better they can deal and interact with them. And that's kind of at the high level that some of the service that we provide. And what makes Neustar very unique is really it's this cool OneID data asset. It's a very highly accurate and a highly authoritative source of identity data. And this along with Neustar's breadth of data and services, and that helps us support and empower our clients so they can build a competitive edge in their market. And as you can see, you know, a lot of the top companies across various different industries, from banking, wireless, insurance, auto, and media, all kinds of industries. A lot of them leverage our Neustar for their services and data and analytics to give them that edge that we talk about. And the thing is, you know, just to manage and basically to build and provide this data source, it's really also a lot of effort, a lot of processing has to go behind the scenes. So there's a lot of changes that happen there. You can see millions of locations, people relocate, phones get changed. All that information has to be processed and updated and kept up to date and accurate. So there's a lot of work and processing has to go behind the scenes to keep the data set up to date and rich and so it can be applicable for real-time analytics. And you know, and you can see here, this slide just shows some of the scope of the changes and processing that happens behind the scenes. You can see here billions of daily inquiries, requests coming in, billions of daily updates, data changes, and all that. And as we try to keep track of all the basically most of the adult population of the U.S. You know, you have all the email addresses, the device location, device information, all the devices that are out there. And then you have basically, we have thousands of attributes. These are mostly like demographic and behavior attributes that we tie all these entities together and keep them up to date and accurate. So all that behind this, a lot of data, a lot of processing, and all that kind of feeds into our analytical platform that we provide to our clients. And here, this slide is just basically shows the different ways that different levels our clients interact with our customers and how we engage our clients. You know, they can be maybe in the planning stage when they're trying to set up a new campaign for their marketing, or they want to understand the behavior of their customers, or reach them offline or online. So there's just different ways that we can interact and help our clients. And this is just to kind of give you just a lot of different ways, and different customers are at different stages in their marketing and how they deal with their clients, their customers. And so some of the high level use cases, and this particular one talks about mobile traffic, foot traffic. So this thing basically, in addition to basically when you do marketing and you kind of want to market to where people live or where they work, there's also where something called transient marketing, where people are during the daytime between work and home. You know, are they going to the mall? Are they going to the ball game? Where do they spend their time in? And so you want to keep track of that and keep that information up to date, and you leverage that information to provide more like real-time marketing analytics to different clients and take advantage of that knowledge. So this is just kind of talks a little bit about that. And I'll show that a little bit in a demo of how we leverage some of that. And Neustar also works closely with our clients across different industries as a kind of a consultant partner kind of relationship, where we kind of try to work with them, understand their problems, and kind of work on the solutions together. So that's kind of some of the stuff here on this slide. And then why use this technology? Why use the data? It's basically use our analytics to more efficiently market to their customers, to select optimal marketing channels, to either optimize store location placements. And again, all that requires accurate and highly predictive data and predictive data modeling. To kind of all that needs to be put together to provide that to our clients. So this is a little bit of a busy slide. And so basically what I want to come across here is that basically we have a very large geospatial database. We got billions of geometries in our environment. Some of them are ranging from simple to really very detailed, like wireless boundaries or congressional districts or different time zone boundaries, or all kinds of areas. Some of these have hundreds of thousands of vertices, are very, very detailed. And we basically do analytics with mobile phone traffic regions, where we track foot traffic, mobile, or basically mobile foot traffic or movement, and then there's lots of data there that we have to process. And then we have, for the cartographic level, we have the road network, the whole U.S. road network, where we have all the ramps, local roads, highways, freeways, and we keep all the relationships between the nodes and the speeds. And so there's millions of nodes and links that are kept, and all this data is kept up to date and processed and optimized. And then we also have all the businesses in the country, and also all the DPC locations, which basically all the addressable locations, such as homes, properties, shopping centers. So all that, and that helps us. We need to keep that up to date for demographic and retrieval, providing analytics to our customers. So a lot of geospatial data in our system, a lot of data. And we have to manage and process all that. We have to manage it securely. We have to perform heavy analytics and a lot of heavy spatial calculations. And at the same time, we have to, because it's a web-based application, as I'll show in the demo, we have to maintain high performance. Our applications like interactive, where people can click on points or areas. They can pan around the map. And all that has to come back. There's some of the process behind the scenes is heavy, and you have to hit different areas and calculate different relationships between spatial calculations. So all that has to work well. And definitely the Oracle technology has really helped us achieve all of this, and help us support and run our application, maintaining the high availability, maintaining the security, system monitoring, and it really provides a really rich application development framework for us to build really complex applications that solve these unique needs for our customers, with all the different things. So we've actually upgraded to Oracle 19c very recently. That's gone really well, and we're looking into the new capabilities there. So we're excited about that as well. So let me go to the next slide. And so, so now I'm going to dive more into kind of the spatial aspect of our application. One thing I would like to say is I don't think most people are aware of this, but there's a lot of spatial data. Basically, spatial data is everywhere. So even if you don't have any spatial polygons, or you don't have a location-based dimension to your data, like latitude, longitude data, chances are there's some spatial connection to your data. And so, like for example, even if you have like transactions that are online, or transactions that are not location-based, chances are those transactions are tied to some business, or they could be tied to somebody in their laptop, buying something online, or someone sitting in a cafe with their mobile device. So there's potentially some spatial connection there. And once you start finding these spatial connections, you can start analyzing data, looking for patterns, and gaining more insight into what you can do. And so, let me go back. And I think one thing I'd like to mention here is, a lot of our clients, because we do a lot of spatial stuff, but we do a lot of things beyond just spatial specific modules. A lot of our clients who even start using our application initially for non-spatial purposes, like they want to do segment coding, they want to basically just better understand their customers, like understand the correlations between the customers, what behaviors, how do you reach them, what type of behaviors do they kind of show. A lot of times they'll start that way, and eventually start using a spatial part of the application, and get a lot of insight and benefit, and really increase their use and value by looking at the spatial insights. So that's something that we've seen a lot with our experience with our customers. And also just want to give a quick shout out to the Spatial Studio tool. I know the previous session Derek and Tim showed was a lot of Spatial Studio usage. You can do a lot of great stuff with that. And the great thing about Spatial is Spatial itself, like I said, it's very rich. There's a lot of stuff you can do. But with the Spatial Studio tool, you can do a lot of stuff without even just very easily, quick drag and drop and do spatial visualizations and do spatial calculations pretty quickly without doing any development and any programming. So it's really a nice tool. If you're new, I definitely encourage you to check it out and take a look at that. So now I'm going to talk about, I want to touch on basically customer use cases with clients that have like franchise type customers, like some type of automobile retailer or a bank, some type of bank branch. And so a lot of the times what clients will want to do, they want to optimize the placement of their branches or their franchise location. They want to basically maximize the number of locations in a market to meet the customer demand, but at the same time with minimal impact of the existing sites. So they want to increase the sales, the network sales, the net sales for the whole market with minimal cannibalization to these existing sister sites. So there's different ways to do this, and one way is to basically create an exclusive trade area that each site will have its own trade area that's very exclusive to that area. And here we have an example where we used non-overlapping radii, and we basically create these 3-mile non-overlapping radii around these 4 or 5 sites, and you can create these markets or trade areas, and then after that you can pull data, and you can kind of pull data for these markets, and you can basically tell how much demand is in that market, in that trade area, how much of a customer, what's the presence of customers and that demographics, and help you analyze and understand your markets better. So this is one example how you can do this. Another really very common use case with our clients is and one thing that's important to them is to basically identify concentrations of households that have a certain behavior or certain high propensity to purchase a certain product. And so that's something really common. And there's there's different ways you can do this. You can theme like component geographies like zip codes or block groups or states or counties, and you can do that. Or you can do tessellations like some type of grids, either square or hexagonal grids, or you can create these dynamic regions. And each of these have different benefits. I mean, the nice thing about using geographies, they're out there, and they're standard, let's say standard areas like zip codes. Those are common areas, but there's pros and cons to each approach. And one of the cons of using geographies is that they vary in size. You have small zip codes, you can have big zip codes. So there's if you have a bigger zip code, chances are you might be pulling more data because it's a bigger area. So you're using like equal size areas like tessellations, like grids, equal 2-mile grids or 1-mile grids or quarter-mile grids. You can create these equal size areas and pull data for these demo, and you can the data is more normalized then, and then you can kind of pull and compare your different areas. And a third approach is using this dynamic regions, which is really nice because it basically constructs regions where there are these high concentrations of the behaviors you're interested in. And then all that behind the scenes are basically we leveraged different Oracle toolkits to build and provide these things. And it's really nice to have that rich capability behind the scenes. And a lot of these functions you have to actually run, a lot of these various different functions like smoothing or connecting to things, constructing shapes and performing different analysis. And it's really very helpful to have that rich toolkit to do that. And so this is another really common need for our clients. It's another important use case. And it's basically to figure out how much driving time is needed for customers to reach a site location. So we have a client, for example, one of our clients manages all the property listings across the US, all the retail property listings that businesses can lease to run their businesses off. And these businesses, when they want to lease these locations, they want to understand, well, how many people are there within 5 minutes, within 10 minutes, within 15-minute driving time to those locations. And it's a really very important need. And the drive time is just a much more accurate way to determine that. You can do an analysis of straight distance, like a straight radius. But many times you can have either an inefficient road network or some river or something that's blocking you, or some mountain. You can't tell from the map directly. So this will tell you exactly what's the driving, what's the extent of all the customers within a driving distance or time to get your potential site. So again, very, very important need that our clients deal with. And the nice thing about this, again, we use the spatial network data model for this capability. And the nice thing is, because like I mentioned earlier in one of my earlier slides, there's a lot of roads in the US, obviously. But behind the scenes, so it has to traverse all the possible roads and all the possible ways. So there's a lot of processing that happens behind the scenes. And the great thing about this is performance is really optimal and scales, and all the Oracle spatial capability has been built to scale and run and process all this for this large data very quickly. So that's really something very, very, very great for us as well. And so just going to different use needs for our customers. One use case, another important customer requirement that we have is basically the ability to switch between different map formats. For example, you can have a quick service restaurant. They may want to analyze a prospective location they want to open up in, potential location that they might want to open. And after they pull the data and they pull the demographics for that area, and they say they're happy with that for that particular location, but then they can go into the application, and quickly they want to maybe look at an aerial to see kind of how the neighborhood looks like, or they want to open up Google Street View and just kind of see how the streets look like, how the nearby stores look like. So all that is really, really helpful. They can do that all within the system. And for us, behind the scenes, using this Oracle spatial projection coordinated transformations that we can do, first of all, they run really optimally and quick performance, but allows it just seamlessly switch between one format to another format, one aerial to different terrain maps or different things you can do. So that's really very, very nice. It makes things really seamless for our customers and our clients. And here I'm going to talk about something that's also been very helpful, is basically, and a common need is to basically consolidate or aggregate different sets of data to make it more meaningful or create something that's more manageable. A lot of times clients will combine different zip codes or block groups or different areas to create larger territories they want to pull data for or maintain their markets in. So that's a common need. And then again, that's behind the scene that runs and processes things really quickly and keeps things accurate. But another need, and I'll show this in a demo, is basically that we had a case where when we were dealing with this mobile location data, the data itself is just gigantic. The mobile device signals are everywhere. Basically, if you look at a map of let's say this small San Diego area, it would basically you'd basically get a carpet of blue points. It would just cover the whole map, and so it was not very meaningful to our customers. Plus, it was a performance problem because we were just dealing with so many points. It was hard to make sense of it. And through different consolidation techniques that we in our Oracle spatial functions that we leverage, we're able to, let's say, consolidate based on some type of metric. In this case, it was the volume of mobile traffic, and create different sized points that represent how much volume there is. As volume decreases, you can create larger points that can represent bigger areas, and create more detail around the more area where there is a greater volume of mobile traffic. So, and with that, you get better performance, and it's more meaningful. And I'll be showing that in a demo in a little bit, so I'll go a little bit more into detail there. So trade area, there's a lot of different shape and ways our clients deal and analyze their markets and their trade areas and their customers. And one approach is if you have if a client has a list of their customers, they can use their customers, list of the customer, load into our system, and basically create a shape that represents, let's say, an X percentage of their customer base, and then that way they have a trade area that really represents a true area that they cover. that they meet with their customers, at least their primary customers. And once they have that, then they can pull demographics, they can pull consumer expenditure data, they can pull behavior data, and kind of understand their customers better, understand kind of the makeup of their customers and who they are, and compare that to other markets and see how things are different. So it's all about getting more information and details for their clients. And so beyond that, I mean, there's just a lot of things you can do with polygons and shapes and combine to create different trade areas. So the spatial toolkit is very, very rich and allows you to do all kinds of stuff with cleansing and fixing and combining and constructing different shapes for different needs. So it's really a very, very powerful and rich capability. And then, like I mentioned also, and this is something very, very important as well. It's, we all know the data is getting larger all the time. And our clients keep pushing the envelope, keep adding they want to process more data. They want to load more data into the system. They want to look at more stuff. So performance is very, very important. And then some of these spatial calculations are very complex and detailed. And many of our the modules or some of the things that we show, we have to actually run multiple different spatial functions to construct these shapes or to do this analysis. And with, I believe it's Oracle 12 release 1, I believe, they really optimized and really boosted the performance of a lot of their core spatial functions. And that has really helped us kind of be more responsive to our clients and also scale better with performance for our reporting analytics and panels and themes and so forth. So that's really a great thing. So I'm going to go to the demo, and we'll go back to the Q&A later in the end. Oops. And let me, hold on a second. Hold on 1 second. Okay. No. Just, and I'm gonna maximize this thing. Let's see here. Doesn't want to maximize, but let's try this one more time. Okay.
So at the moment, we're still seeing your Q&A slide.
Oh. Oh, sorry. Yes. Okay, I need to change the sharing. 1 second. Sorry. Okay, I guess I go to new share. Okay. Thank you, Hans, for that. Okay, can you guys see the different screen now?
Yes, we can.
Okay, and I don't know why it doesn't want to go full screen for some reason. Interesting. Okay, well, let me try one more thing here. Let's see here. No. Okay, well, I wanted to make it full screen, but for some reason doesn't want to do that. Okay, no problem. Well, okay, so this is our initial application connection welcome screen, and I'm going to go into our mapping part of our application, and I'm gonna start with a different map initially. Okay, and I'm going to zoom out. So I'm going to show some of just the different trade area, the site location, site analytics kind of analysis that we do. So here's an example of, I have these locations, these 5 prospect sites that I'm looking at, and so what I'm gonna do here, I'm gonna select them, and hold on. And I'll do, few seconds. So here I'm gonna, so these trade areas that you're looking at here are basically exclusive trade areas for these 5 locations, and they're basically zip code component areas. So combined or zip code aggregated trade areas. So I basically I create these trade areas using non-overlapping zip codes based on some type of radius approach. And then if I try to pull data for these areas, let's say I'm going to pull the beer, Samuel Adams, the households that drink Samuel Adams beer the most in this area, and I can minimize this now. And basically, so you can see the different areas. So this area, this trade area has the most highest beer drinking, and then you have the less, and then the blue area here is the least area. So these are all unique exclusive trades. So this is one approach of creating trade areas where they can be exclusive to an area. It can be a combination of component geography. So that's one approach. Now I'm gonna clear this theme now. Let's do this here. It's a shame that I can't maximize the screen because it looks. And I have a small laptop that I'm using as well. But let me try one more time.
Do you want to try F11?
I'm trying to click F11, but it doesn't want to work for some reason. Let's. Oh, there. Okay, so it did work. Okay. Oh. Okay, now we're good. Good. That's probably better, hopefully. So now I'm going to clear this theme, and I'm gonna basically create another trade areas. So these guys are already selected. I'm going to modify these trade areas, and I'm going to create basically here. We're going to pick a non-overlapping radii, and I can say, let's say 3-mile radius. So this is a different approach. Instead of using a component or aggregated component geographies like zip codes, I'm going to use a different approach behind the scenes where it's going to create these radii, and now you have these individual locations, these individual trade areas that are also still exclusive because each market is unique to that area. And I'm going to open up the theme again here, and this time let's pick something different. Let's pick like coffee. I drink a lot of coffee. A lot of developers drink a lot of coffee here, so I'm going to pick. Let's pull some variable. And one of the great things about really the Neustar provides is we have these thousands of attributes that are accessible to your finger points to pull data for in your analysis. So I'm going to pick just drink coffee, ready to drink households with coffee, and let's here select that, and then I'm going to I want to pull data for those markets. So I'm going to pick that layer, and I want to pick areas on the map. So it's going to pull for these areas, and then it's going to be just the areas on the map. So instead of just all the square window, and then I think I'll run it. So now you can see for drinking coffee, this is also a higher area for coffee drinkers, and then the blue is the less area. So if you had like a coffee retail, a quick service restaurant, and you have these 5 businesses, you can see that this one is actually, these 2 have an advantage over the businesses that are here, just because it happens to have more households that drink coffee in this area. So now I'm going to let's see, let's change something here. Let's go to the theme, and I'm going to, so let's say I want to drill down and further into these areas, and I want to kind of get more details, because this is, you know that all these areas have these number of households that drink coffee, but where in the trade area where are the concentrations of that behavior in that trade area? So I'm going to do something a little bit different, where we're going to, instead of pulling theming or pulling data for these markets or these trade areas, I'm going to break it into layers, component geography layers. In this case, I'll pick block groups, which is block groups are very small geography, and I'm going to instead of doing touch, I'm going to do centroid within. So this will pull only the block groups are mostly included within this market. And then I'm going to, let's change the theme here a little bit to something more, yeah, here, sorry. Let's change it to this. and then just run it. Hold on a second. That's no, I want to do it. Areas on map. Okay, let's do this again. So now you can see now, because block groups are a lot smaller areas, and so now you can see. Let's see that basically the orange areas are the highest coffee drinking locations, and the purple are the least. So within the markets, that gives you a more finer grained kind of view of analysis on your data. And then once you have that, you can go and open up info panels and pull more data for your markets, for your areas. So I'm gonna open up this particular one. No, hold on. Close this. So I'm going to pull for this area, and then if you let's make this a little bit bigger here, and then also this one. Let's just let's maybe increase this here. So you can see the demographics. Here we're looking at data by occupation type, and then core demographic types or education. Completed different levels of different education attainment levels, from advanced degree to college level to high school, and demographics. So you can pull, and then you can also pull data for individual markets or these different trade areas, or the block groups themselves. Let's say I want to pull for that block group here. Let's zoom out a little bit. And here, so one of the reasons it's hard to pull for the markets is because the areas are above, the trades are above the actual zip code, the block group level, but that can be changed very easily. If you go to layers and change that. So, but the idea here is that you pull data, and you can pull for markets or trade areas for your analysis, and then you can drill down further, deeper down into individual components. So now I'm gonna, like I mentioned before, you can see here some of the block groups they vary in size. Some block groups are large, some block groups are smaller. Let me close the panel here. So they vary in size. So this is one of the things when you're using geography. They're useful because they're standard component areas, but they have those other pros and cons of that. So I'm gonna remove the theme now. Let me remove this. And I'm going to, let me actually also maybe close all trade areas. Yeah, and I'll maybe just open up this particular one and zoom in closer. So if I wanted to understand this thing a little bit further, and well, actually, yes, okay. And I'm gonna do a theme, and this is where I will maybe let's create a new theme. And I'm gonna pick. We can stick with the coffee variables for now. Start. No, hold on. And then okay, hold on a second. Let me select this. And then I'm going to switch to grids. And let me zoom in. I'll zoom in a second. And then what I'll do is I'll create like a 0.5 mile grid. 0.5 mile grid. Square grids, we can use square around the area on the map that I have there. And I don't want any buffer. Buffer is useful if you have like a large area and you want to create grids around like a 1 mile, 2 mile buffer around the area. So that would be when you would use buffers. And I'm going to run this grid creation there. So this will, and I'm going to zoom into this area because I zoomed out too far. So again, this gives you a different analysis, a different view, where you can now see stuff by these equal-sized tessellations, and you can pull data for these tessellations. And so that's one approach of kind of creating that need. So solving the problem with pulling data for either component geographies or equal-sized shapes, or I can also quickly show creating a heat map. And heat maps are nice because they're built on using this irregular triangulations, and that the Spatial provides, and it's a way kind of to measure like the elevation of a map. If you're looking at terrain of mountains and valleys, where you have the high elevation, but here instead of elevation in the geospatial marketing world, it could be any data set. It could be coffee drinkers or whatever, or whatever variable you're interested in pulling data for, and then you would pull the data for that area. So it's basically behind the scenes. It has to create all these triangles, and then measure, create these scores based on the area. So it creates these dynamic regions that you can pull data for, and you can see, okay, this is the area where there's a actually it's the purple as the purple at the lower, but then you have the orange is where the highest coffee concentration of coffee drinkers are. So those are just some examples of just pulling data, visualizing information based on and behind the scenes running all this. And you can see it's very snappy. We use all the Oracle stuff, and it does a lot of stuff behind the scenes to do these things, but it's really very snappy. So now I'm gonna switch to something different. I'm gonna focus. Go to one more use case here. Let me turn off this grid here, this theme. And I'll switch to a mobile location map. We don't need to save it. So here, and let me also open up a legend here so you can see what's going on here. So basically, what you have here is, let me also zoom in. So basically, this is a San Diego area, and what we've done, like I mentioned earlier, we basically kept track of all the mobile device signals across time for an area, and like I said, there's a lot of signals, and the signals everywhere initially. And what we did is we basically organized it by traffic volume. So there was more mobile traffic volume, that and also the presence of retail, if there's any retail location or any important basic retail, or if there's an important point like a marketplace or something that's like a transportation hub. We would store more fine level details. So you can see here around the freeways, there's more. You have more of these small 25-meter points. These 25-meter points each represent basically tracking of mobile and the count of mobile devices per time. And as there's less mobile volume, we kind of created as a mobile traffic volume decreased, we basically create larger areas to represent those areas. So you can see 50-meter, 100, all the way up to 800 meters. So the larger orange areas are typically areas where there's less activity, but less foot traffic happening. And then where there's a very small blue ones, there's a lot of foot traffic happening. So this gives you can visualize where there's a lot of activity happening. And it's much more useful than just having this carpet points of you basically just cover the whole map with this blue carpet, and you wouldn't be able to tell. So this kind of you can visualize areas where there's a lot of things happening. You can see this is downtown San Diego, a lot of stuff's happening here. But then here across the island to the Coronado Island, there's a section where there's a lot less volume, and you can have these 400-meter locations to track your device, because there's a lot less happening here. You don't need as much fine detail. But there's something, and this little area here, there's obviously something more busy in that space. So that's kind of a way to kind of organize and consolidate a very large data set into a meaningful and make it run optimally and perform well. So here I created some shapes in this demo. I created some shape like this Petco Park, this ball game park, and also created some shapes here around in the San Diego Airport area. So let's see here. So here I have the San Diego Airport. I have basically Terminal 1. Oh, it's actually Terminal 1 here and Terminal 2. And you can get really close to the terminal, and you can see the different parts of the terminal. And we have these data points. We have a lot of detail around the terminal area. You can see here most of the mobile traffic volumes happening at the terminals themselves. And as you get further away, some of these points on the runway are just basically people sitting in their plane, and it's capturing somebody working, and it's capturing those device locations. So, but then okay, what we do with Neustar, which is really pretty amazing. We take the data, the device traffic signal locations, and we append or we segment code them. Basically, attach a segment code for that. And once you have a segment code, a Neustar element 1 segment code, we can project that. We can project that into different behaviors and or demographics or different data, and you can get more details or insight onto who's in that area at what time. So I'm going to open up a panel here, example panel, mobile traffic volume panel, and so I'm gonna hold on a second. No, minimize this, and I'm gonna basically pull data for one of this for this, and I'm gonna, because this thing's not, we don't have a lot of space here, so I'm going to maybe minimize this for a second here. So this thing basically shows by different times of the day, the consumption of imported beer drinking that's happening in that, or the people that are in that airport, what type of beer do they drink, and at what time, different times of the day. And for example, here, it's like you can see Corona is the highest beer, the most popular beer for those people at that airport at that time. And then you go to Guinness and different types of beers. And then I can look at the other airport across here and pull data for that airport, for that terminal, I'm sorry. And you can see it's still, I mean, Corona is the highest, and different types of beer. And then you can get summary of I think in this case, let me maximize this. Hold on, no. So you can see the beer drinking, different beer product types by different device brands, with Android versus iPhone or other. And here we have an index which shows, it's either, I think it's index or households, I'm not sure, but if it's index, it basically shows compared to the base, how more likely are these beer drinkers in that area compared to the general base of everybody else. So it's very, very, very useful information. And then basically you can pull, basically, this is for the whole terminal, but you can actually drill down and you can go to this particular area in the terminal, because we have these distribution points, and pull data for who likes to sit in this particular area in that terminal and get data for that. And then basically, oh, sorry, I didn't want to do that. Let me click back on this. Open info panel. There. Okay, so I'm gonna let's minimize this here, and let's go to Pi. So you can then pick different. No, I didn't want to do that, but sorry. Well, basically, what I wanted to show is, let me try this one more time. What I wanted to show is basically, it's a little bit hard because this is a small laptop that I'm using, unfortunately. But basically, what I'm trying to do here is, oh, here, good. No, I didn't want to do that either. What I basically want to show is, let me try it one more time. Options. Oh, no. Oh, it's okay. Well, what I want to show is you can pick different variables, and you can pick coffee, or we have tons of data in our system. That's really the strength of E1 is all the data is available to you to do your analysis. Like if I go into theme here, like I showed a while ago, and I want to run a particular theme, the variables we have, if you go to the, cancel this, but I'm going to, so basically there's thousands of product potential by, things from apparel to automotive, to computer, to, lifestyle choices, to all kinds of travel and shopping, so it's just and then consumer expenditure, how much dollars are spent on different product types. Just a lot of data assets really available to you to do, and you can kind of switch them back and forth, and you can also switch, between different time periods and analyze your information. So that's kind of all. We're trying to make it as seamless and easy for our customers, make it so it flows really well and nicely with our customers. But that's kind of what we do. So that's kind of my demo for this. Now here I also have, for example, the San Diego car rental center. So I wanted to pull data for that and analyze that as well. So the whole point is that we just want to show you some different examples and use cases, how we use spatial to solve different things, and more from a geo-marketing kind of perspective, but how it's been very helpful for us and continues to be very, very great to solving this really very creative solutions for us. So I think, Hans, I'll hand it back to you.
Yes, Nick, thanks a ton. That I found that very, very amazing. The complexity of analysis you have managed to get under control here is quite mind-boggling. Plus, you have tons of data, which actually leads us to the open questions, which we have. There's two questions from Alan Hagen about the location data, in particular the location data get from mobile clients. The first question was how detailed that is, and if it's restricted, which brings us to the topic of data security, statistics, and the like. Do you want to briefly comment on that, Nick?
Yeah, absolutely. It's actually, that's a really good question. So we the data that we have in our E1, it is summarized. So each of these 25, 50 meter, 100, so it's summarized, and we just basically store the unique device count. So the unique device counts, but because we have the segment codes, so we don't have no sensitive data in our system because we don't want to deal with sensitive restricted data. And it's to us, it's something that we don't want to deal with that headache basically. But we have segment codes, and segment codes basically is a way to classify individuals into a particular group. And we have these, I think, 1 to 172 different segment codes. But statistically and analytically, using those segment codes, we have a high analytical capability high chance to predict propensity to purchase different products and to be in different based on the segment code. We can do a lot, and that's proven based on our marketing and analytic capability. So it's a way we don't have to deal with any sensitive data, but we can still have all the valuable analytics in our environment.
Brilliant. Okay, there's an additional question from Therese about what percentage of data do you need permission to obtain? Sorry, what percentage of data do you need permission to obtain? Yes.
What percentage of data? I'm not sure I follow that. What percentage of data?
I guess it's also related to the question of sensitivity and
oh yeah,
where does your accuracy end? I guess once you go below block group level or household level, I assume that this is maybe what it is referring to. But Teresa, maybe you can yes, that seems to be the
yeah.
question.
So we in element 1 everything is summarized, and we have most of the detailed demographics and financial and all the attributes are summarized at the block group level. But we do have at the very Z4 level. Z4 is like basically we just keep track of so that we don't have any sensitive data stored because everything is summarizable. But at the Z9 level, for to be able to calculate proportions of how much populations are within a particular area, we just have population count compared to, so we can calculate accurately the proportions of population to a custom area. So we thought through these kind of stuff to make it as especially in the world now with everything is sensitivity is very important. So we want to make things as not restrictive as possible and manage that.
Yep. Okay, excellent. Great. So we're coming up to the top of the hour. So my suggestion would be that if anybody still has any questions to Nick, do join Nick over in the Slack workspace. Now that we have the chat under control, everybody should be able to see the link to the Slack workspace. So just click on the link to the Slack workspace, or use the shortened URL bit.ly/andouc-slack. That should get you to the Slack workspace. So if you haven't seen it, maybe just quickly grab this. So if you haven't